Students, we know that there are different systems of units, and in the SI system, we do have 7 fundamental physical quantities. So, those physical quantities, the units of those physical quantities are the units of the derived physical quantities. If we wanted to express them, we need to follow a set of rules and regulations. Okay. So, let us now look at some of the rules and regulations to be followed while writing the units of the physical quantities, whether they be the fundamental physical quantities or the derived physical quantities. Okay. So, let us look at them one by one. So, here first one, I am taking some physical quantities, their correct representation and their wrong representation. Okay, just observe this. First one is say mass. So, mass, the correct representation is kg, k in the lowercase, g in the lowercase. Okay, and here wrong representation is this. Length is there, m and m. Time is there, s and s here. So, do you identify any difference between the two? What is the difference between the wrong correct representation and the wrong representation? The first one, if you see, k, g, both are in the lowercase, whereas here it is in the uppercase. Okay, whereas here same way, m is in the lowercase, here it is in the uppercase. Here s is in the lowercase, this is in the uppercase. Means what? We should not use the units or represent the units in the uppercase. So, symbols for units should be in lowercase. Okay. Though there are certain exceptions, we will discuss them. Okay. So, when I say kg, what is k? You will be able to learn in the coming time. Okay. No problem about that. So, this is one particular rule where you say that the units, symbols for units should be in the lowercase with some exceptions. What are those exceptions? We will see now. Okay. Let us go for the next rule. Okay. So, now I will show you some of the things. See, temperature, length, time. The correct representation, the wrong representation. In the earlier examples, we showed only the units of the physical quantities. Here, I am writing the name of the units. Temperature is written in Kelvin, length in meter, time second. Okay. So, when you see the wrong representation over here, again see Kelvin K in the uppercase, meter M in the uppercase, second S in the uppercase. Means what? That means even if you don't, if you write the unit in the name, that means full form, not showing only the symbol of the unit, I am writing the complete name of the unit. Even in such a case also, I need to write them in the lowercase only. Even though, see, if you consider these three, among these three, Kelvin is the name of the unit which is named after a scientist. Okay, it is a unit of temperature named after a scientist. Okay. So, similarly, even if it is named after a scientist or not, so you should begin with a lowercase, even though it is named after a scientist. That is the rule. Okay. These two units are not the names of the scientist, but this is the name of a scientist. Even though when you are writing in full, you should begin with a lowercase letter. That's it. Okay. Hope this rule is clear now. Let us go for the next rule. I am showing again some physical quantities like this. Now you see, I am representing both of them. That means what? The unit and in name and as well as in the symbol form. Both I have written here. So, these are the correct representations, these are the wrong representation. So, what is the difference if you observe here? Here temperature, electric current, force. Out of these three, you can identify the first two. These are nothing but the fundamental physical quantities that we have seen. Okay. So, force is a derived physical quantity. Its unit is in Newton. You know Newton is a very good famous scientist over here. Right. So, when I write the full name of the unit, this N should be in the lowercase. Okay. So, names should be in the lowercase even if they are named after the scientist. But symbols, if I am writing, they are represented in the uppercase. All these three units are named after the scientists only. So, the wrong representation you can see here, the difference between these two is here, name is written with a starting uppercase letter. These two are okay. But when I write the symbol form, it is written in the lowercase. That is wrong. So, symbol should be written in the uppercase, whereas name should be written in the lowercase. So, that makes them a wrong representation, whereas this is right. So, the rule says that symbol of a unit named after a scientist should begin with an uppercase letter. That's the rule. Okay. Next one. You see these particular things again: area, speed, density. Other set of examples what I am taking the physical quantities. So, now you can see very clearly all these three are derived physical quantities. For measuring area, we need length and time, length and breadth. For speed, we need length and time. And for density, we need length as well as mass. That means mass per unit volume. So, for volume again, you need length, breadth and height. Basically, all the three being length in. Okay. So, here I will say correct representation m square, whereas here is m square with full stop over here. Okay. Here you can see m s power minus 1 speed, whereas here is full stop. Kg per meter cube, full stop. So, from these observations, can you identify what is the rule to be followed? Yes, have a guess? You are right. We should not put a full stop at the end of the unit. Now, a question will come like, for suppose if I say this particular unit is coming at the end of a sentence, then how? We know as per the English punctuation, after a sentence ends, we'll keep a full stop over there, indicating that the sentence is completed. Suppose I say a boy is running at a speed of 3 meters per second. My sentence ends over there. When I write 3 meters per second, 3 meters per second, if I write that way and then put a full stop over there. So, because it is coming at the end of a sentence, there should not be a problem. Okay. But if at all it is coming in the middle of a sentence, then it is a problem. For example, if I say a train traveling at 20 meters per second increases its speed to 30 meters per second. Okay. This sentence, if you write a train traveling at 20 meters per second increases its speed to 30 meters per second in 5 minutes. Okay. So, at the end of the sentence, I got 5 minutes. That means in 5 minutes, the speed is increasing. That is the meaning of the sentence. So, if I write 5 minutes at the end, there I can put a full stop because it is the end of the sentence. But in the middle, where I am telling 20 meters per second to 30 meters per second or whatever the value, there I cannot put a full stop. Clear? So, the rule says that we should not put the full stop at the end of the unit over there until and unless it is at the end of a sentence. Symbol of a unit should not be followed by a full stop except when it ends in a sentence. That is the simplest rule. Is this rule clear? We will go to the next unit, next rule. Okay. See the units over here and the physical quantities and the units over here. Quantity I am taking length, force and mass. So, here I am telling 10 meter or m, whereas here I say 10 meters or ms. Mass 5 kilogram or kg if I am writing, 5 kilograms or kgs. Force 3 Newton or N. This is 3 Newtons or Ns. So, these are all the correct representation. This is the wrong representation. What do you infer from this? What should be the rule? Yes, you are right. We should not write the plural form of the unit. Unit means only one. Unit is always one. Colloquially, people say 10 meters, 2 meters, 3 meters per second, but it is, as per physics, it is using that way, it is wrong. Okay. So, the rule says that units and their symbols should never be written in plural. I cannot write this way. Okay. So, colloquially people say while speaking, but when you write this way, you should not represent that way. So, if you make up the habit of speaking also like in the singular form for the units, then it should be better for you. So that when you write also, you will not make any mistake. Clear? So, now this is one particular rule. Now, let us look at the next rule. Okay. So, here I am representing some physical quantities. These are also the derived physical quantities, torque, speed and density. Out of these two you will be able to know, that is speed and density. Torque, you don't understand what is torque. Basically, I will say force into distance. That is how you measure the torque. Okay. So, you learn more about the torque at higher classes. Don't worry right now for what is torque. But it is a product of force and displacement, or force and length basically. So, force is measured in Newton, length is measured in meter. Okay. So, Newton meter I will write like this, or I will write Newton meter. For speed, if I am writing meters per second or meter per second. Density, kilogram per meter cube or kilogram per meter cubic meter. This is how I am writing. So, one way I am representing only the notation symbol, or I am writing the full name of the unit. Okay. So, now all these three are the derived physical quantities. Now, this which involve more than one physical quantity. The physical quantities which are involved in this particular physical quantities may be again fundamental or derived. As an example, I will say density is equal to K mass by volume. Mass is what? Fundamental physical quantity. Volume is a derived physical quantity, right? Agreed, na? So, when I am using, one is a fundamental physical quantity, other is a derived physical quantity. If I am clubbing those two, then I can call the unit of that particular physical quantity a compound unit. Okay. So, kg per meter cube is a compound unit. Similarly, speed, mass by time, in the length by time, that is speed, not mass by time, it is mistake. Speed is length by time, distance by time. So, distance is basically length. Time is again fundamental quantity. So, both the units involved over here are fundamental. When you say torque, torque is force into distance. If I use that way, distance is basically length, that is a fundamental, but force is a derived physical quantity. Okay. So, like that, I can have in a derived physical quantity one or more fundamental quantities or one or more derived physical quantities. In these scenarios, whatever the units you are showing, you will call them as the compound units. When you are writing the compound units, you cannot club one symbol and one name of the unit. You cannot write like Newton meter. You want to write Newton meter, you write in full Newton meter. Or you want to write in a symbol form, you write symbol Nm, that's it. So, half of the unit you are taking the symbol notation and half of the unit you are taking the naming notation, that is not right. Okay. So, meter per second, this way writing is wrong. You write like meter per second this way, or you completely write meter per second. Okay. So, the rule says that you cannot club unit symbols and names mixed with in an expression. That is the rule to be followed. Okay. Now, we will go on to the next rule. Right. Here I am taking 4 physical quantities: area, time, volume, speed. Almost all the things are familiar to you. Right. Here I am writing meter square. This is second, centimeter cube, meter per second. These are the correct representation. Now, here you have the wrong representation. M square. What I am writing here? Square meter. And I am writing SQ dot M for square meter. Okay. So, second I am writing SCC. Centimeter cube I am writing CC. CC stands for cubic centimeter. Okay. So, MS, MPS. So, you might have habit of writing certain units like this. For writing second SCC, not required. You cannot use the type of abbreviations whatever you wanted to do. Okay. Whatever the agreed symbols are there, agreed notations are there, which are acceptable, which are given by the SI system, only those are to be used. You cannot use the way you like the abbreviations. You cannot write like SCC for second or MPS for meter per second. m and s power minus 1 slash, fine, or m slash s, sorry, m and m with space and s power minus 1, that is fine, or m slash s is also fine. I cannot write MPS this way, stating that meter per second. This is the wrong notation. So, that is what the rule says. Abbreviations should not be used in the unit symbols or unit names. Very clear. Okay. Next rule, let us see. I am taking area 5 meter square, 10 second, 20 centimeter cube, 50 meters per second. This way, this is the correct representation. Certain numbers we are taking over here and certain units. Fine. Now, see the wrong representation. Just observe both of them. What is the difference you are getting? First one, here I have 5 and m, there is a space. Second one, there is no space. Same is the case with the other things also. See here, 50 meter per second, m and s, there is a space over here. Whereas here there is no space. Even for 0 and m also, in 50 the 5 0, but between 0 and m also there is a space. Whereas here there is no space between the two. Clear? And if you write this way, 50, okay, there is a space over here. But what is wrong here? There is no space between m and s. Clear? So, there should be a space between the number as well as the unit. Even you write the unit in the name of the unit or the symbol form. Here this example, name of the unit is written, whereas this example unit is written, the symbol for the unit is written. Okay. So, whatever the way you write, either the name of the unit you write or the notation, the symbol notation you use, wherever you, whatever the type you use, but you need to have one space between what? The number as well as the unit. If it is a compound unit like meter per second, you need to give space between the individual units also. Clear? So, kilometer per hour if I write, okay, I need not give space between, let me show you that one. Okay. If I write that kilometer per hour, say kilometer per hour, this is right, or else I can write kilometer per hour. This is also right. I am talking about the unit of speed. Fine. These two are the right way of writing. Okay. If I write this way, that is wrong. This is wrong, whereas these two are right. Okay. So, kilometer, even though it is not the unit, when I say kilogram, something like this. So, kilogram, kilometer, nanometer, something like this. We will come to know why we should not give space between these two in the coming things. Okay. So, this is one particular unit. Let us now go with the other one. So, here what is the rule? That so space should be provided between a number and its unit and also between two units in a compound unit. Compound unit is what I am referring to this. Clear? Let us go to the next rule. Okay. So, here see, length 3 centimeter, time 10 nanosecond, volume 20 centimeter cube, speed 60 kilometers per hour. So, here I am writing, this is what I just mentioned over here, right. So, when I say 3 centimeter, what is wrong over here? Between C and M, there is a space, that is wrong. And what is wrong over here? See, 60 km h power minus 1. There is no space between the 0 and k, that is a mistake. Or else, here what is happening? Between 0 and k, there is a space. But you can observe very clearly, between k and m, there is a space over here. So, here giving, if you do delete the space, that is mistake. If you give the space here, that is mistake. You should not give space between k and m, whereas you should give space between 0 and k. Same way here, centimeter, C and m, you should not give space. Here, that is a mistake. What is this centi? What is this? Here also nanosecond, n and s. If I am writing this way, 10 nanosecond. What is the gap over here? See, here between nano and second there is no space. Here also there is a space. So, space between the number and the unit I am writing, this is okay. Here I do not have space between nano and second. Same way, notation wise, if I am writing symbols, I am writing ns. Here there is no gap between 0 and n in the case of 10 nano, but there is a given gap between nano and second. So, giving spaces here is wrong, not giving spaces here is also wrong. So, what does the rule says? What does this centi, nanos and kilo stand for? These are the prefixes. Okay. Space should not be left between a multiple or submultiple and the unit. There is a symbol. You should not give space between what? Multiple or submultiple and the unit. What is the multiple or submultiple? Centi is a submultiple. Kilo is a multiple. Okay. Nano is a submultiple. Clear? So, when you take submultiples or multiples of the units, between the multiples and submultiples and the units, you should not give space. If you give space, that is wrong. Okay. Hope this particular rule is clear. Now, we will go on to the next rule. See. Let us see the next rule. Here, I am having length, time, volume, speed. Okay. So, if you see very clearly the difference between correct explanation and wrong explanation, first one you see 3 centimeter, 3 centimeter. Time 10 nanoseconds I am talking about here is 10 nanosecond. Volume I am talking about is 20 centimeter cube, here 20 centimeter cube. Speed I am writing 60 kilometers per hour and here it is 60 kilometers per hour this way. Now, you try to observe carefully the difference between the correct explanation, correct representation and the wrong representation. Okay. What do you have here? I am talking about centimeter, nanosecond, centimeter cube, kilometer per hour. Okay. So, I know meter, second, these things. Time also I say second and hour, that is I know. But when I say centimeter or nanosecond, kilometer, these are nothing but prefixes or suffixes. Okay. That means which are coming before the unit actually. So, generally